So I finished filling it in. When C is greater than 0, that means when C is positive, we're going to have a shift right. Remember that the minus sign in there with that C means that if C is positive, you're going to, when you look at the equation, you're going to see a minus. The minus is part of the equation. We plugged in a positive 2, so the minus with the positive 2 stays looking like x minus 2. That's going to shift it to the right too. If C is negative, you're actually going to see a positive sign, because when you plug in, when you have x minus a negative 2, the minus the negative 2 lets you see a plus 2. So what you see in the equation is actually opposite of what the value of C is. C is the opposite of what you see. That should be sticking in by now. C is the opposite of what you see. So we see a minus 2, so that means that we have a positive 2. It's going to shift right. We see a plus 2, that means we actually have a negative 2. That means we're going to shift left 2. And I'm going to show you on Desmos what all of that looks like. Having a D value. Now, most of the time we do put the D value at the end, like I've done right here. This is the square root of x plus 5. That's going to shift it up 5. This is the square root of x minus 5. That's going to shift it down 5. D behaves exactly the way you think. Sometimes, though, to make sure that we don't confuse, does the 5 go underneath the square root or not? Sometimes they put the 5 in front. But there must be some sort of addition or subtraction symbol between the D and the square root. If it's not, if you do not see a plus or a minus sign, that means it's an A value because you're multiplying. So you have to see that plus or a minus sign. This would shift it up 5 because this 5 is positive. This would shift it down 5 because the 5 is negative. Do not get confused with this problem. Y equals 5 minus x squared. That has two transformations. It has a D value of positive 5, which means it's going to shift up. It's going to shift up 5. And then that negative right there is a negative 1 that's being multiplied times that x. So we have A is negative, and that's going to reflect it. Okay, so be careful when you see a problem like that. 5 minus the square root, that does shift up 5, but the minus in front of the square root of x is the same thing as having a negative 1 being multiplied by that, which causes a reflection. All right, now B is going to make things a little bit more complicated. First of all, sometimes the B has to be factored out, okay? In order to identify what C is, there should not be a coefficient in front of the x. So in other words, if I see the square root of 2x plus 3, that 3, let me make it an even number. If I see 2x plus 6, that 6 is not C. I'm going to say that again. That 6 is not C. Why? Because the coefficient of the x is a 2. This needs to be rewritten as 2 times x plus 3. Now you can see that the C value is actually negative 3 and the B value is 2. Okay, so that's the first thing you have to be very careful. That's why over here I have the B outside the parentheses. The x minus C, that coefficient of the x is a 1. So if you are given something that looks like 2x plus 6, then the first thing you should understand is you have to factor out that 2 so that you can see what the actual value of C is, and then you'll have the value of C and the 2. Now, also notice that the B is kind of like A because it's a multiplier. So some of the things that are true about A are going to be true about B. B is also kind of like C because it's underneath the square root with the C. So the fact that C causes things to change left and right, that's going to be true about the B. It's going to cause things to change left and right. But it's like A in that it's going to cause some shrinks and stretches and reflections, but it's like C because it's going to make all of those things horizontal, and it's also going to make things the opposite of what you think. So we're going to move over to Desmos real quick and watch some transformations so I can explain what I'm talking about. So let's jump over there real quick. Okay, so I've typed in the general equation. I've put A on the outside. I put B underneath the radical with the parentheses and the minus C, close the parentheses. I did all of that. I typed it in just like I have it written down. And of course, we can see that if we plug in positive C values, it shifts to the right. And oh, by the way, the parent function has a C that, so when you see, if all you see written down is y equals the square root of x, it still has values A, B, and C there. It's just that A is 1, B is 1, C is 0, D is 0. D is going to move it up and down. We can see D moves it up and down. The parent function has a D value of 0. If A is negative, you see it reflects it across the x-axis. If A is a decimal, you see it's the closer the decimal is, it gets closer to the x-axis. If A is bigger than 1, it's moving away from the x-axis. And then B is going to be similar to the same thing. My A needs to be 1. So when B is a number that's between 0 and 1, it looks like right now that it's getting closer to the x-axis, but I'm going to show you in just a second that it's actually doing something different. But I will show you this: when B is negative, it reflects over the y-axis. So we do have a reflection. It just reflects it over the y-axis. When it is bigger than 1, it looks like it's getting farther away from the x-axis, but actually what it's doing is getting closer to the y-axis. And then the same thing is true when it's a decimal. It looks like it's getting closer to the x-axis, but what it's actually doing is getting further away from the y-axis. So the things that we're going to write down over here are going to be the opposite. And I'm going to show you very detailed in a minute what I mean. So when B is negative, we get a reflection over the y-axis. So that's what's different. What changes? Oh, I forgot to go back and tell you what changes on these. So when you change C right here, when you change C, of course the endpoint changes. So it changes both the domain and the range. And then C moves it left and right. Yeah, because it's moving the endpoint, so that changes the domain and the range. And when D changes, it also changes the domain and range. And then when B reflects it over the y-axis, you change the domain because you're now going this direction. So you're going from negative infinity and you're stopping at your endpoint. So you change your domain, and you also change your end behavior. So your end behavior changes because you now have left end behavior, because if you're going this direction, you're going to the left. And if you're going to the left, then your end behavior is now, as x goes to the left, my y is going to go either up or down, depending on how it's flipping. So reflecting it changes your domain, and it also changes your end behavior. And then B is going to be just like A. You're going to ignore the sign of B, and if B is greater than 1, or you can have ignoring the sign of B, you can have it between 0 and 1. So it's kind of like A, that it has the same changes, but what happens right here is different. Because why? B's inside, just like C is, and C behaves the opposite of what we see. So B is going to behave the opposite of what we see. When B is bigger, it's actually going to cause a compression and a horizontal compression. And what that means, it's going to get closer to the y-axis. It's going to get closer to y-axis. And moving it closer to the y-axis actually makes it look like it's getting taller, but it's not. We're compressing it, moving closer to the x-axis. And when it's a fraction or a decimal, it's going to be a stretch. And if we see that B is a 2, then the compression is going to be by 1/2, where we flip it. And if B is a 1/2, we're going to say that it's a stretch by 2. Again, we flip it. So if we see like this number right here, if B is 2, then we say it's a compression by a factor of 1/2. If we have a 1/2, then we actually say it's a stretch by 2. So we flip B upside down.